Yep.
You're on mute, Mr. Strauss.
So now give me a thumbs up if you can hear me at home. All right. So like I said, even though there wasn't a place to upload this homework, I'm glad that you did it because it's important. There'll be a question like this on the test on Tuesday. Okay. We'll do a little review on Tuesday and then we'll take the test, all right? Yep. So the question is, how many are you going to have to do on the test? Well, let's go through the homework and then I'll answer that question, Lily, I promise. Okay. So I am just going to do number 10 because as you probably noticed, as you did these, you're basically repeating the one before, just adding one more electron. Okay. So I'm going to start with number 10. And it's 1s2, 2s2, 2p6. So there are 10 electrons for neon. So I have my first 2 electrons go in the 1s. The next 2 electrons go in the 2s. And then I go 1, 2, 3, 4, 5, 6. Okay. You feeling okay, RJ? So let's do the 1s 2 electrons first. Because if I've got 10 electrons, Keegan, I should have 10 addresses. Okay. If I have 10 friends, I'm going to send out 10 letters, 10 invitations to my party. So the first thing we're going to do is the 2 red ones. They're both in the first energy level. Now, if you are in an S, L is always 0. So, whoa. So I know my L will be 0. M sub L is L to negative L. So if L is 0, my M sub L must be 0. One is spin up, one is spin down. Okay. Then I move on to my two s2 electrons. So here I'm in the second energy level. Well, what about my S there, Maria? What is the L value for S? 0. S is always 0. And if L is 0, when I plug it in for M sub L, then this has to be 0. When your electron is in an S, L is always 0. And then one is spinning up, one is spinning down. Now, there are many possible answers to some of these. This one, there isn't, but for the other ones, there are many possible answers. And so, believe it or not, usually people get this question on the test right, just simply because there are so many possible correct answers. But for this one, the P's, they're all in the second energy level. So there's 6 of them. So there are 6 electrons. Now they're in the P, right? So if they're in the P level R's, what's my L value? 1. So P's are always 1. So then when P becomes 1, or when L becomes 1, now when we plug it in, M sub L goes from 1 to -1. That's why there are 3 p orbitals, 1, 0, and -1. Two of each. Now, how you fill them up, it doesn't matter. So usually it's just easier to follow a pattern. So like for me, you put 1 in each before you double them up. So me personally, I like to go 1, 0, -1. And I put them all spin up. So I've got the first 3 electrons that go in, 1, 0, -1. And again, it doesn't really matter the order you do it. And then I double them up. So then I go back and I put their buddy in, but their friend has to be spin down. Okay. So that now Lily said, well, how is this going to look on the test? Well, I might ask you to do all the quantum numbers. If I was going to do that, I'd probably pick something small like beryllium or boron, because this takes a while to do all the quantum numbers. Another thing I could do would be something like this. Give me the quantum numbers for all the valence for germanium. Give me the quantum numbers for germanium. Just the valence. The quantum numbers are like the address, quantum address. So the configuration is argon. I can write better than that. Germanium, the configuration is argon, 4s2, 3d10, 4p2. So if I was just going to do the valence ones, Lily, it would just be those 4. So I could say, just give me the valence electrons, and then you'd say, okay, my 4s2s are n equal to 4, L0, M subscript 0, plus 1/2. So that would be for the 4s2s. And then the 4p2s would be P's are always ones. S's are always zeros. And then again, this is where like you'd have options. So there'd be many possible correct answers because you could have, that would be one possibility. So as long as you give me one correct answer, you got it right. So like I said, this would be an example of a problem. Does that make sense, Lily? And again, I'm not going to say give me all correct answers. That would take way too long. Just one possible correct answer. So any questions from you Zoomies at home? Alrighty, when there's one last thing to learn then. And then we're going to start our next unit. So in quantum mechanics, we have to learn excited state, ground state, and impossible state. So a good one to do this with is lithium. So lithium is 1s2, 2s1. There's no place to put this. You just have to put it in your notebook or in Notability, just somewhere. It's ground state, excited state, and possible state. So ground state is when all the electrons are in their lowest possible orbitals. I want to get this down. So when all the electrons are in the lowest possible orbitals. So I'm going to use red here, so it's easier to see. So those are my 3 electrons, okay, for lithium. Now, as you know, Mike, I can excite electrons. So I can make the electrons jump to a higher level. I got to put energy in, but I can make the electron jump to a higher level. That's called excited state. So for example, if it was 1s2, 4f1, that would be excited. So the electron should be all the way down in the 2s, but it's not. I excited it up to the 4f. So if it's not in the lowest available orbital, Keegan, we say it's excited. Now, what happens when that electron falls back down? What does it release? It releases energy in the form of light. Okay, so when electrons fall, they give off energy in the form of light. So you got excited and ground. So this would be excited state. So any questions on the difference between excited and ground?
You just have to like know that for the class.
You have to be able to identify, is it a ground state or is it an excited state?
So if it was just like 1s2,
If it skips a bunch, it's excited, okay? And then there's impossible state. An impossible state cannot exist. So here's an example of an impossible state. Magnesium, 1s2, 2s2, 2p6, 2d2. So what's impossible about this? 3s is supposed to come first, and is there such thing as a 2d? No. So impossible state is something that's literally impossible. It doesn't exist. How about this one? Silicon, 1s2, 2s2, 2p8, 3s2. What's impossible about this one? You can't have a 2p8, right? The maximum Evan is 6. How about this one? What is this one? And let's stick with silicon. 1s2, 2s2, 2p6, 3s2, 3p1, 4s1. Is it excited, ground, or impossible? So let's, here's a silicon. This is ground state for silicon. But if I kick one up into the 4s, now it's excited. So this one's ground. This one would be excited. I think that's the example I did. Yep. So there's on the practice test, there's some problems like this. So you can get some practice on these. All right. So even though, Lars, I'm not making the practice test due, I'd still highly suggest that you do it. Okay, Keith. So I'm not making it an assignment, but I think it'd be a great idea to see the types of questions on the test. And here is something that people forget. I don't know if they forget to study or if they just don't study it enough, Jader. But you know, study the 4 quantum numbers. Remember, like, what do they stand for? What does L stand for? Angular momentum, or the sublevels. So some of these have multiple answers. You know, what does M subscript L stand for? It's the magnetic quantum number. You know, what are their values? What do they change on the graph? So don't forget to study that one, okay? Because that's an 8-point question on the test. There's like 60 points on the test. So, you know, 8 points out of 60, that's, you know, a big chunk of the test. The magnetic quantum number, it said that when charged particles move, they create magnetic fields. So we know the electron appears to be spinning, right? right? That's what spin is. The electron appears to be spinning. The magnetic quantum value, M subscript L, is the magnetic quantum value. Why is it taking a chunk out of it? There we go. So if the electron is rotating, it's going to create a magnetic field. Magnets have a north pole and a south pole. If the electron is rotating in the other direction, it's going to create a south pole and a north pole. So when you develop these theories, you're like, okay, so what? Who cares? All right. So these things have magnetic fields. Great. Well, what happens when two magnets of opposite poles approach? What do? They attract, right? And if they're like poles, they'll repel. So we can use this information to create things. And one of the things they thought was, okay, if these electrons have magnetic fields, I should be able to get them to flip if I bring a bigger magnet nearby. And when you flip from one state to another, whoops, when electrons flip from one state to another, they release a small, tiny radio signal, a radio wave. So if I could detect that, I could measure the location of the electrons, more or less. So this was postulated in the 1920s. 60 years later, they built this machine. It's called an MRI. I'm going to switch over to my computer here because I want to show you this demo. Okay. Oops. You guys can hear me at home okay, right? Argon 4s1. That's me. I don't know, that happened last time too. There's like a time delay. I only have to do the orbital or the valence electron, so 4s1.
So they say they can hear you.
Yeah,
So at home, when they-
they shouldn't be hearing me do this again. It'll go away.
Sulfur -2. We're gonna do neutral sulfur first.
Wow, so this is how boring I really am.
Sulfur would be
So Terry, you didn't have to agree.
neon,
You can be like, no, Mr. Strauss.
S2,
Okay, let me share my screen.
P4. That's neutral sulfur. Now if it's -2.
Where is that
I'm
coming
gonna
from?
Change that 4 to a 6. Because if it's negative, I gain 2 electrons. Right? So the outermost would be.
Got a video playing up there.
How do I have a video playing up there?
What are you doing?
Okay.
It's one of your tabs.
Oh, there we go.
Like,
Bye-bye. That'll do it. All right. So here's if you go to FET Colorado, there's tons and tons of cool demos. I know I've showed you this before, but we're going to go to MRI. How many of you have had an MRI before? Only 3 of us? Oh, 4 of us? I go get them just for fun. All right, so this is what there's you, okay? Half of your electrons are in the spin up state, half of them are in the spin down state, 50-50. If I turn on a magnetic field, boop, 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 turn on my magnet, Crank up the magnetic field. Well, actually, that's the power. This is magnetic field. So I turn my magnetic field on, and guess what happens? Almost all the electrons go to a spin-up state. Now, when I turn the magnet off, half of them will fall back down, and as they fall, well, you didn't show it right there. They'll release radio waves. So I turn my magnet on. They go to the spin-up state. I turn my magnet off, and as they fall, come on, radio waves. Why aren't they showing the radio waves coming out? Turn the magnet on. Turn the magnet off. See, there are the radio waves coming out now. And those radio waves will hit the detector, and then they can map where everything on the inside of your body is. So MRI uses magnets, okay? Here's a little trivia question for you. When MRIs were first developed, they're called NMRIs. So I can put this in the chat room. Come on. So they were first called NMRIs. So can anybody tell me, why do you think they got rid of the letter N and just call them MRIs? They took off the word nuclear. Why did they take off the word nuclear? It scared people. You want me to get into a nuclear machine? Are you crazy? I'm going to come out like green and fight crime on the streets of New York and eat pizza like the Ninja Turtles. So people were like, no, I'm not getting in it. So they dropped the letter N off. It's called magnetic resonance imaging. And now then, Keegan, people are like, oh, magnets. I like magnets. I played with them as a kid. So I'll get in the machine for you. So human nature. The other thing, like if you want to like do marketing in science, this is sort of a tangent here, Maddie, but whenever they market drugs, they come out with a new drug, they spend a lot of time figuring out the name of it. Okay, there's a whole psychology behind the name of drugs. Anything that's got a S sound, a C, a soft C, or an X conveys speed. Zantac. Okay, that's for antacids. Zantac. Cialis. No, not NyQuil. If it's got a hard consonant, like a hard C, k, or a D, or a T, that conveys strength. So claritin, strong. That doesn't work for me either anymore. But strong, so if you're going to market something and you want to convey strength, you use hard consonants. If you want to convey speed, Zyrtec, yep, Zyrtec. That's why they have all those names, those strange names. It's not like Frugerschmiegel, the whatever. You get the idea. All right, there's one other thing I'm going to go, we're going to review for the test here. One other demo. I'm going to have to turn the lights. I'm going to risk turning the lights off in the room because it's easier to see. You can play with this at home too. All right, so we're going to review the models of the atom. So the very first model was billiard ball. So what's going to happen if we shoot light at a billiard ball? What's going to happen to the light? Should bounce off. So here's the prediction. but this is what really happened. Went straight through. So one bounced off, but they should all be bouncing off, right? So the atom cannot be a billiard ball. So therefore it's pudding. So if I shoot light at a pudding, the electron should bounce around. But Thomson was wrong. Then we go to the nuclear model. With the nuclear model, you've got the electron orbiting the nucleus. However, the electron is negative, the proton is positive. They should attract each other and do this. Boom. But as we know, your atoms are not exploding. So that's why Bohr said, I think the electrons are quantized. They can only orbit at certain distances. And when I shoot light at it, I can make my electron jump to higher levels. There, it just jumped to the second. Now what happens when the electron falls back down, Ian? Should give off light. Let's see, does it? There it is. It just gave off that photon of light. Speed this up just a tad. Okay, there it jumped all the way up to the sixth. Now, does it have to fall all the way down? No, it could fall there and there. Doesn't have to fall all the way down. On the first, eventually it'll fall all the way down. Oh, it fell down to the fifth. Down to the second. There, released blue light. And then release some more light. Now, the thing with Bohr is he said, I don't know why you can only orbit certain distances. And that's where de Broglie came along. And de Broglie said, we need to stop thinking of the electron as a little sphere. The electron is also a wave. And that wave oscillates. And so now when I shoot light at it, my waves can only come, as we know, waves can only come in certain numbers. 1, 2, 3, 4, 5, whole numbers. So let's see if I can speed this up here. There. My wave jumped out to the fifth energy level. N equal to 5 amplitudes. 1, 2, 3, 4, 5. There it's easier to see my wave. Oh, there it fell down to the second. N equal to 2. And this is the reason why the waves are quantized, because there I'm at N equal to 6. 6 amplitudes. 1, 2, 3, 4, 5, 6. And if you incorporate both the wave and particle properties, we get Schrodinger. So what you see here is the probability graph. That's the 1s. Come on, Avery. Avery, are you feeling okay? If you're feeling okay, then I need you to pay attention. If you're not feeling okay, I can send you to the nurse. Oops, I got to shoot light at it. Okay, so that jumped out to the p orbital. It's kind of hard to see, but there's a p orbital there. I'll stop it when we get to a really good p. That's fifth energy level, the 5p. The 5p is a dumbbell inside a dumbbell inside a dumbbell inside a dumbbell. This is the 3p. This is a little bit easier to see. There's one dumbbell, and then another dumbbell. So the third energy level, angular momentum 1, which means a P, and then the magnetic value is 0, which means it's on the Z-axis. There's a good easy P. See, there's my dumbbell. Second energy level, L equal to 1, which means a P orbital. M sub L means it's on the X-axis. And then when it falls, it's going to release light. There, it fell, and it's releasing light right there. This is the 3P. The 3P is a dumbbell inside a dumbbell. So it's jumping between these orbitals. Here is the 3P on the X-axis. A dumbbell inside a dumbbell. I really would like, oh, there's a nice P again. I would really like to see an S. There's another P. P orbital. P orbital. P orbital. There we go. There's the 2S, a sphere within a sphere. Okay, so we'll be excited up in the 2S. When it falls, it'll release energy. Oh, it jumped higher. There, it released it. Let's see if we can get an F. Last class, we got a 4F. I know I think I might give up. Oh, well, I don't think we're going to get an F orbital. So I'm going to switch back over to the iPad. Okay. Turn on the lights. Well, first, somebody left this here. Somebody left some cotton sitting out here. Yeah, cotton. Yeah, but you know, as a chemist, I'm always interested to classify things. You think it would start on fire?
Yeah. Oh.
He's trying to kill me.
I was trying it to see. So that's called magician's paper. So it temporarily blinds you so that the magician can put the rabbit in your hat.
Yeah, no kidding.
What?
No
I felt the
kidding.
heat from here.
Jeez, I couldn't see for like 2 seconds.
I know, but it worked.
My heart didn't work for a couple of seconds.
You ended way over there.
Oh, that what you smell is the sulfur in the cotton. I can do it again at the end of class.
Bro, I thought he was about to turn into. Oh, shit. I'm glad I didn't scream. Your eyebrows were damn near gone. If I scream.
No, I know what I'm doing.
So
to make that stuff is actually quite dangerous. I got to soak it in acid for a whole day. Then I got to rinse it out, then soak it in a different acid for 2 days. And I'm talking really strong acid. And then I got to rinse it with water again and then let it dry. So it takes 3 days to make that stuff. So
Worth it. Yeah.
what?
Worth it.
Oh, it is worth it. That's why I go into chemistry, because
Just Maddie's real. Yeah, and it was like funny because we didn't know what was gonna happen. No, yeah, I was like,
I was like, why the heck did somebody forget hot?
Every chem teacher has a little bit of pyro in them. All right, so
Try that at home.
there's no way you can buy that stuff online, but it's a little bit expensive. But to make it takes a lot. I gotta wear a mask and a ventilator because the acid's so bad. All right, so so you guys at home, I just set something on fire. That's all. So we will do the math on the lab on Wednesday. For the last 15 minutes before we have work time, I wanted to just start bonding. And again, this is kind of why we learn quantum mechanics, is because it explains the behavior of elements. So Lewis dot structures is a way to represent electrons, valence electrons. So given a generalized atom, let's say element X, the s orbitals go on the right side and the p's go on the top and the other three sides, okay? So you want to write this down somewhere in your notes, wherever you keep notes, whether it's Notability or on a piece of paper. So suppose we were going to do nitrogen. No, let's do phosphorus. Phosphorus is 1s2, 2s2, 2p6, 3s2, 3p3. Lewis dot, after Professor Lewis, I think he was at the University of Chicago. I could be wrong. You guys can hear me at home okay, right?
Yeah.
Okay. So there's my configuration, Chloe. And Lewis dot structures are only for the valence. So all the S and P's in the outermost level are the valence. So I would put 2 dots right here for my S's. And then I would put 3 dots going around it for my P's. All right, you don't double up the P's until you have to. So Lewis dot structures are a way of representing the electrons. Pretty soon, in like 5 minutes, we start putting atoms together. Right now, we've just been studying single atoms. How about neon? Neon's 1s2, 2s2, 2p6. What would its Lewis dot structure look like? There's 2 in the S, right? And then it's got 6 P's. Just like humans, electrons do not like to be alone. They want to be paired up. So look at neon. Everybody's paired. That's why neon does not react. Okay. Phosphorus, it's got 3 single electrons. So phosphorus has 3 friends that are single. So phosphorus is going to have to find 3 dates. Electronegativity is the ability of an atom to attract electrons to itself. When in a bond. Kind of think of it as like rating the attractiveness of elements. So some elements are more attractive than others. They can steal or borrow electrons better than others. So electronegativity is the ability of an atom to attract electrons to itself when it's in a bond. What do you think you want to do for a career, RJ? Business? Business, there's a lot you can do in business. Marketing, accounting, sales, management, shipping, receiving. All right, so there's a, oh shoot. There you go. There's a chart for electronegativity. Now, where is it? There it is. So this is Appendix O, and it tells you which elements are the strongest, which ones are the weakest. Fluorine is the strongest at 4.10. Francium is the weakest at 0.86. If the difference between two elements is greater than 1.7, then your bond will be ionic, okay? I'm going to abbreviate electronegativity with the letters EN. So if the electronegativity is 1.7 or greater, your bond is ionic. If you're less than 1.7, your bond will be covalent. And we want to know the bond because it predicts behavior. So for example, ionics dissolve in water and conduct electricity. Covalent don't dissolve in water and don't conduct electricity. So if we know if a substance is ionic, we know then it'll conduct. We also know it'll dissolve. If something is covalent, then we know it won't dissolve and we know it won't conduct electricity. Below what? Covalent. So the definition of ionic is electrons are stolen. Covalent, electrons are shared. So ionic, electrons are stolen. Covalent, electrons are shared. So let's do an example. Let's do a couple examples of ionic. And let's do sodium chloride. So this is why we study quantum mechanics. So we've got sodium over here, chlorine over here. Sodium is neon 3s1. Chlorine is neon 3s2, 3p5. So what we have here, Andrew, is sodium has one valence electron. And chlorine has 5 valence electrons. I'm going to use X's for the chlorine. So sodium has 1, chlorine has 7. Now, what do you do if you got one friend who's single and another friend who's single? Try to set them up, right? Try to make them a couple. Well, now the question is, are they going to share or are they going to steal? So what we have to do is we have to go find the electronegativity difference of sodium and chlorine. So I go to, here's my chart. Sodium is 1.01, chlorine is 2.83. That's Appendix O. You wouldn't have to memorize these. This is something you would look up. So 1.01, 2.83. You take the absolute value of the difference. Okay, Amanda, the absolute value of the difference. So when I do that subtraction there, Alyssa, I get 1.82. Those numbers came from Appendix O. Come on, Keith, you got good friends. You're smart not to name who your friends are. So 1.01, 2.83. So what's going to happen here, Alyssa? Is my bond going to be ionic or is my bond going to be covalent?
Ionic.
Yeah, because it's above 1.7, it's going to be ionic. So what that means is the chlorine is so strong, it's just going to steal that electron from the sodium and take it. So what happens, Abraham, when you gain an electron? What happens to your charge when you gain electrons? Do electrons have positive or negative charges? Negative, other way around. So if I gain one electron, I'm going to become negative. Sodium lost an electron, so it will become positive. I put brackets around it. So you might think, Keith, that sodium would be pissed off at chlorine, but what about opposites? They attract. So the sodium and the chlorine bond together because they are opposites in charge. So even though chlorine was a bully and stole the electron, let's do one more example, and then we're done with notes. So magnesium fluoride. I've got one magnesium and 2 fluorines. I put the magnesium in the center because I have fewer of them. I put the fluorines on the outside because I have more of them. So whatever element you have more of, you put around the outside, Lola. Since I got 2 fluorines, I put them on the outside. Since I have only one magnesium, I put it in the center. how many valence electrons does magnesium have? So you can do the configuration, but the fast way to do it, Ion, is to look at the periodic table. Where's my periodic table? Where's my periodic table? That's my son.
Oh.
He's got blonde hair.
You just look down.
There it is. You used to have blonde hair?
Oh, it was afro, curly, blonde.
So sodium is in group 1A. I'm sorry, we're doing magnesium. Magnesium is in group 2A, so it's going to have 2 valence. If you're in group 3A, you have 3 valence. If you've group 4A, 4 valence. Group 5A, 5 valence, and so on and so forth. So you can do the configuration, or you could say fluorine's in 7A, fluorine's going to have 7 valence. So my fluorine's going to be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. My magnesium has 2. I take the difference between the 2. Where did I get those numbers from? You got to go back to Appendix O. Oh, I got magnesium wrong. Sorry. Magnesium is 1.23. Fluorine is 4.10. Sorry about that. So I take the difference. So there's my difference. So Megan, is that one going to be ionic or covalent?
Ionic.
Ionic. So if you're ionic, you're going to steal. So one fluorine steals 1. The other fluorine steals the other one. This one's got a -1 charge. And what's going to be the charge on my magnesium there? How many did it lose? 2. So it's going to be +2. Will magnesium fluoride conduct electricity? Yeah, it's ionic. Will it dissolve in water? Yeah. All right, so we're starting to link quantum theory to predicting the properties of things. And that's what chemists do. When we make new things, we have to know properties so that we can predict their behavior. So to wrap this up, I got a summary here. Just a 2-minute thing that just really wraps it all up. It is a song. Who just said ooh? That's right.
Far below.
No.
Just a little
All right.
atom.
So, sorry guys at home, I'm not going to stream this because it glitches too much. But you guys here, I suppose you guys at home can always mute me. You always have that option, but people in the classroom don't have the option of muting me. So this is the sodium chloride blues.
No.
Yes.
No. No.
Here we go. Ready?
Chlorine.
Valence -1.
Swimming in the sea, digging the sea, and just having fun. Sodium swimming in that sea. Worry about the shape or size of her outside shell. It's fun to ionize a little atom of Cl with an unfilled shell. Right? Chlorine's got that unfilled shell. Now somewhere in that sea lurks handsome sodium. Isn't sodium handsome? With enough electrons in its outside shell, plus that extra one. So, yep, even the internet didn't want me to sing. I guess I froze. So, but I have to upload this. So, because there is a student missing, so I have to upload this. So you can always go onto Canvas and listen to it as many times as you want. No, that's not me singing. But I'm actually in a barbershop quartet. Yes, I am.
Prove it.
I've got practice tonight.
Sure you do.
I can sing. Let me call you sweetheart, I'm in love with you. Let me hear you whisper that you love me too. Because they'll keep singing and they won't stop. All right, so I have always wanted to do that. But we don't have advisory this year. I shouldn't say we don't have A+ this year. So next year, barbershop. All right, okay. For homework, Chapter 8 vocabulary review. Both sides, front and back. Okay. So Ion, Celia, Chloe, Emma, Keith, Megan, Mike, make sure you've got do Chapter 8 vocab review front and back. Optional is the practice test. So that's the chapter 8 vocab review. Now, I want you to study the correct answers. So I will just show you that the answers to these are in Canvas. So the practice test answers are in the packet, but if you go into Canvas, the answers, there's the where you upload it, but the answers are a little bit further down. So there are the answers. So do the worksheet first, you guys. Okay, Abraham, do the worksheet first, then check your answers. Okay, you got 20 minutes. I bet you get this worksheet done. So it's a lot of fill in the blank. Okay. Do you guys have any questions at home? I will try to reestablish connection with my iPad, but I will mute myself and be checking the chat. The vocab review is locked? No. Let me check that again. Oh, yep, something's wrong with, here we go. I'll fix it, Alyssa. There we go. Okay, Alyssa, it should be available now. It should be available for all you guys now. Okay? Oh.
I will, but I just want to know what this is.
I'll be there in a second. It's gonna be like that practice test, with multiple choice, short answer.
You would give us. We couldn't give it to you.
Oh, that's what it's for.
Mr. Strauss, you still have the other unmuted.
You really get stuck on it.
Why is my number?
Mr. Strauss,
Oh, someone's talking on the
Okay,
chat.
the number of choices.
Mr. Strauss,
How many words?
You just told me that was the wrong one and now you're
No,
on.
I know, I just wanted to know what the orbital pair meant, so I could do it when I got home.
What, Keith?
you still got the other device unmuted.
Oh, okay. How you guys doing at home? Got any questions? Alyssa, Andrew, Ayan, Celia, Chloe, Keith, Megan, Mike?